This is our last review lesson. It is on linear inequalities in one variable. The essential question is, how do you solve different types of linear inequalities in one variable? An inequality is very similar to an equation. You solve it by finding all the values for the variable that make the inequality true. So let's look at an example. So let's say we've got 2x plus 2 is greater than 4. How do we go about solving this? Well, initially we're going to treat this exactly the same way we would if this were an equation. We're going to start by subtracting 2, then we're going to divide by 2. So by the steps you can see that we come down to x being greater than 1. So let's look at another example. How about 5x minus 7 is greater than 3x plus 9? Again, we want to get the x's on one side, the numbers on the other side. So again, we treat it like an equation. We add 7 to both sides. We subtract 3x from both sides, which yields 2x is greater than 16. If we divide by 2, then we get x is greater than 8. Now, the previous two examples were considered a single inequality, since I had just one inequality symbol in each expression. What if we have a double inequality expression? So let's look at this example. Let's say I've got minus 3 is less than 6x minus 1 is less than 3. Notice we have two inequalities here. Again, we treat it like an equation, and notice I have the term 6x minus 1 in the middle, so I want to get rid of the minus 1, so I add 1 to the left of the first inequality, between the two inequalities, and to the right of the second inequality. So this yields minus 2 is less than 6x is less than 4. Now if I go ahead and divide by 6, I should get my final answer. Then our final answer, therefore, is minus 1/3 is less than x is less than 2/3. Now, the final inequality we are going to talk about is solving an absolute value inequality. So let's say I've got the absolute value of x minus 5 is less than 2. Now remember, absolute value is always going to be positive. But what's inside the absolute value could be positive or negative. And that gives me my next answer. So now I can remove the absolute value sign and rewrite this as minus 2 is less than x minus 5 is less than 2. Now this only works when you got a less than sign. Now at this point we can treat it just the way we did the previous example. Add 5 to both sides and come up with our answer. So now, once we have added 5 in all three locations, we should be able to come up with our final answer. So, as you can see, our final answer becomes 3 is less than x is less than 7. So the other version of an absolute value inequality is when you have a greater than sign, or in this case we've got the absolute value of x plus 3 is greater than 7. Okay, we're not going to treat this the same way as it was before, because now we have a greater than, so we have to treat this as two separate problems. So again, we know what's inside the absolute value could be positive or negative, but in this case with the greater than sign, we end up with x plus 3 is less than minus 7, or x plus 3 is greater than plus 7. Now, we solve each of these individually. So our final answer for this problem is x is less than minus 10, or x is greater than 4. Okay, so if you think of this on a number line, the solution would be to the left of minus 10 and to the right of 4.